Have you ever wondered what is actually happening inside your students' heads when they have that aha moment? Well, today we're going to pull back the curtain and look at the incredible, always changing world of the student brain. We're going to dive into the science of how they learn, and more importantly, how you can use that knowledge to make your teaching even more powerful.
I mean, it's the question every single one of us asks, right? Why does a lesson just click for one student, but another really has to grapple with it? How can one kid pick up a new language so easily, while another is a natural athlete? Well, it turns out the answer is actually found in the very structure of their brains.
You know, for the longest time, the common belief was that after childhood, your brain was pretty much set in stone. The only changes happening were, well, not good ones, like aging or injury. But thanks to incredible technology like MRI scans, we can now see that's just completely wrong. The brain is always changing.
And this incredible ability for the brain to keep changing has a name: neuroplasticity. And listen, this isn't just a metaphor. I mean this literally. Every single time a student learns something new, whether it's a math equation or how to play a new chord on the guitar, they are physically, tangibly changing the structure and the function of their brain.
So how does that actually work? How does practicing a skill or memorizing a fact become a physical part of the brain? Well, it really boils down to three core ways the brain makes these changes.
So the brain can change its chemical signaling, it can change its physical structure, and it can change its functional organization, basically how efficient its networks are. And all three of these work together to support everything from that first flicker of understanding to total mastery.
Okay, this slide explains an experience we've all had. Think about a student practicing piano. During that one session, they're getting better, and they get that "I've got it" feeling. That's a chemical change. It's fast, it's temporary, just a little boost in chemical signals between their neurons. But when they come back the next day, it feels like they've gone backwards. Why? Because that short-term chemical rush didn't have time to become a long-term structural change, where the brain physically builds stronger connections. Real, lasting learning, that takes building something permanent.
And I really do mean physically. This isn't just about stronger connections between cells. With consistent, focused practice, the actual parts of the brain responsible for that skill can grow larger. It's just like building a muscle at the gym.
And this chart shows it perfectly. Researchers have seen that expert musicians have larger motor regions in their brains. People who read Braille develop larger sensory areas for their fingertips. And one of the most famous examples, London taxi drivers who have to memorize this ridiculously complex map of the city actually grow larger brain regions for spatial memory. The work they do literally reshapes their brain.
Okay, so this brings us to a really critical point for us in the classroom. And it might seem a little backwards at first. If building those structural changes is the goal, how do we get our students there? Well, the answer isn't to make things easier. It's to actually embrace the struggle. This is the key takeaway right here. When a student is really wrestling with a tough problem, that very effort, that feeling of difficulty is exactly what's driving deep, structural change in their brain. So the struggle isn't a sign that they're failing. It's literally the feeling of their brain rewiring itself for the long haul.
But here's the thing. Neuroplasticity is kind of a double-edged sword. The brain is shaped by everything you practice, but it's also shaped by everything you don't practice. We can build positive pathways by mastering new concepts and developing good study habits, but we can just as easily build negative ones, reinforcing bad habits, misconceptions, or even anxiety. And if a skill isn't used, the brain will eventually prune those connections away to use the space for something else. It is truly a use it or lose it system.
So, if every single student's brain is constantly changing based on their own unique life experiences, what does that mean for how we teach? Well, it means that the whole idea of a single, one-size-fits-all approach to learning is basically destined to fail.
We've all heard of the 10,000-hour rule, right? The idea that it takes this specific amount of time to master something, but the science of neuroplasticity shows us it's just not that simple. For some of your students, mastery might come way faster. For others, it could take a lot longer. Their journey is as unique as their brain is. So here's the bottom line. Because every brain is shaped by a completely unique set of experiences, there just isn't a single recipe for learning that works for everyone. This brain-to-brain variability, it used to be seen as a problem for researchers, but now we understand it's actually the most critical factor in how people learn.
And this leads us directly to the idea of personalized learning. And look, this isn't just some new trend in education, it's a biological necessity. It's all about tailoring our instruction to match the unique brain of each individual student so they can achieve the best possible outcomes.
So how do you even begin to do this in a busy classroom? Well, you can start by becoming a kind of learning detective. Just observe. Watch how different students tackle a new problem. When you introduce a new, challenging task, notice where that productive struggle is happening for different kids. And most importantly, ask them. Encourage them to think about their own thinking. A student who realizes, hey, I learn math best with hands-on tools, but I learn history best by listening to stories. That's a student who is gaining a powerful insight into their own neural wiring.
All right, let's pull all of this together. Understanding neuroplasticity really changes your role as a teacher. You're not just delivering content from a curriculum. You are actively, physically guiding the development of your students' brains. You're a brain builder.
And probably the most important lesson from all of this research is there are no shortcuts. There's no magic pill for learning, no neuroplasticity drug you can take. The single most powerful driver of brain change is behavior. To learn, to build a better brain, your students just have to do the work.
So what does the work look like? Think of it like a daily workout routine for the brain. First, short, consistent, focused practice. That's what forges those lasting structural changes. Second, designing tasks that create that sweet spot of productive struggle. Third, helping students repeat healthy behaviors and mindsets while also helping them spot and break the negative ones. And finally, and this is a big one, prioritizing quality sleep. Sleep is not downtime for the brain. It's the critical time when the brain gets to work consolidating the day's learning and cementing all those new connections you help them build.
You see, every lesson you teach, every challenge you pose, every word of encouragement you offer, it is all physically shaping the brain sitting in your classroom. That is an incredible power, and it's a profound responsibility. You're helping your students build the very brains they will use for the rest of their lives. So that leaves us with the most important question of all. What kind of brains will you build tomorrow?